It's really something standing up here and seeing so many faces coming to learn about AI, to participate in the tech ecosystem of Armenia, both locals and foreigners as well who have come here to participate in all of this. It's really a testament to the amazing work that UATE and the community has done over the last 20 years to shape the ecosystem and bring Armenia into the forefront of technology in a way that's not just amazing for a small country like Armenia and the region, but amongst the world. We have the opportunity in Armenia to be truly world-class and be important to the world and for far more than just being a place, being a crossroads between other places. The key to achieving this is our only natural resource. It's our brains, the talent that is within the Armenians that live here. And here we are showing what's possible with the discontinuous change that artificial intelligence is bringing. We now have an opportunity to make a step function leap into this future where we can be truly world-class and important to everyone else and bring prosperity not just to ourselves but to others. So with this talk, I'd like to talk to you about essentially two things that are interrelated. First, maybe I can explain to you guys what AI is to some extent. I know we've been talking about it a lot. Everybody knows it's important. There's a lot of dollars and money being thrown around. We talk about AI as this potentially amazing technology that can do all these things, as this scary thing. Is it a bubble? Is it not a bubble? What's involved with it? And then I want to talk to you about how we can harness what's happening with AI for Armenia, how we can build Armenia into an AI nation. The story for this actually started quite a while ago. Back in 2018, when Prime Minister Pashinyan first became Prime Minister, I came out here along with a few other technologists to advise the new Prime Minister on what we can do to enhance the tech sector in Armenia. This is a very promising time and a great opportunity, and he listened. Soon after, the Prime Minister came and visited NVIDIA, who I don't think I need to tell you guys about NVIDIA anymore. A few years ago, none of you really knew NVIDIA, but these days it seems all of you know. We happen to be the largest company in the world at the moment for a little while. But in 2019, we were not the largest company in the world, although we were still very important. And the Prime Minister came to visit us at NVIDIA. Here's a picture of our CEO, Jensen Huang, with the Prime Minister. It just so happens that the Armenian Prime Minister is the first head of state to ever come to NVIDIA, well before all the other ones. Nowadays, they are all lining up to come visit us, but Armenia gets to claim this first. In this meeting, the Prime Minister learned a lot about technology, about our technology. Jensen, our CEO, graciously spent a lot of time with him, showing him demos and all of the technologies that we have. Later on, our president also visited and got a lot of the same experience and treatment. But at one point, we had a small meeting, and in this meeting, the Prime Minister asked Jensen, what should Armenia do in order to build its tech sector? Because high-tech technology is really Armenia's only hope towards having a great economy, of having an economy that will fuel peace and prosperity for the country and in the region. And Jensen's answer was very simple. He told them, do for your people what I've done for my people. Now, this is 2019, mind you, a few years before ChatGPT, but we were well into building all of the fundamental infrastructure, all of the fundamental needs for creating artificial intelligence. We understood that in order to build artificial intelligence, in order to build software in the future, in order to do the frontier of computer science, you need a basic instrument of this science. And that basic instrument is a supercomputer. There's a list called the top 500 supercomputers in the world that's been there for decades. At that moment in time, NVIDIA had 3 out of the top 20. The rest of them were all national laboratories. They belonged to the United States government, Japan, etc. But there were 3 of them that belonged to just NVIDIA. We owned it, and we built it, as Jensen said, for our people, for our engineers and researchers. Number 3 on the list was NVIDIA Selene. It was ours. So he explained to the Prime Minister that if you want your people to be on the forefront of this technology, then you have to give them the basic instruments. You have to do for them what we did for our people at NVIDIA, and the idea started from there. So we worked for a few years to try to figure out how to get a supercomputer built here, and we did it in earnest. But unfortunately, it wasn't quite the right time. ChatGPT hadn't happened yet. The demand wasn't quite clear. The demand signals from the local community as well as globally. And then we had a war, we had COVID, we had all these other things which kind of put it on hold. I don't know why this thing's not working. Thank you. All right. But in 2022, we built an office in Armenia. NVIDIA opened an office here, which gave us an opportunity to explore rekindling this project. And soon after we opened the office here, ChatGPT happened. The whole world started to understand what the power of this technology might be, and the demand for this kind of supercomputing factory had exploded already. And soon after, Jensen came to visit Armenia. He came and met with the Prime Minister again, and this time we had the same conversation. Jensen gave him the same advice, and the Prime Minister really understood, and the others that were present as well also understood. And so we set about going to do the same project again. Now, what is a supercomputer? For most people in this room, for most people everywhere, the idea is this abstract thing. We all kind of know what a computer is. We type on them, and there's some in your pockets. But what makes one a supercomputer? The idea of a supercomputer is that it's essentially one of these computers, but scaled up to be very, very big. That's what makes it super. But it's not enough to just have many of these computers. They have to be built in such a way that it acts as one machine, like one factory. You can put one program, one set of work into this machine, and it does this one thing, but at a very, very large scale. It turns out that for the kind of compute that we need in order to do artificial intelligence, this is the only real way to do it. We have to process so much data and convert all of this data into these very special numbers. The only way you can do such a thing is by building a computer at very large scale. What we do at NVIDIA is we build the whole thing. We're known for building chips. We're called a chip maker and a chip company. That's true, we design chips. But in order to build such a thing, to build such a supercomputer, it requires much more than that. You have to take these chips and you have to build systems that consist of every element of the computer, specifically designed to be accelerated, be such high performance that it can do things that no normal computer can do. Then you take this basic unit and you combine them together into a big space, what we traditionally call data centers, feed it lots of power, and scale it up. And what these supercomputers actually start to become is not just some computer that you place inside your house or inside a closet somewhere. They're essentially big infrastructure. They're infrastructure like a factory. They're infrastructure like power generation. They're infrastructure like a bridge or a dam. And so building this kind of infrastructure requires many elements. You have to have land. You have to have power. Arguably the most important part of this, of the mix here. The biggest limitation is always how much power can you secure to provide such a thing? And you need to have shell, the actual place to put it in, designed specifically in order to deal with all of the heat that is generated inside the system. And you need to have connectivity to the internet to move all of the data across. There's many, many elements to it. Now, the purpose of these things, these supercomputers that we're building for AI, is not like traditional computers. All of you have probably heard of data centers, hyperscalers. These are the things, the computers that we place inside data centers for powering the internet, for serving web pages, for doing financial transactions, for storing data. We call them data centers because it's all about data. It's about moving data around or storing data. They're more like warehouses, but for ones and zeros, for information. You store and move things around. What we're building now with these AI data centers is not like that. It's not like a warehouse. It's more like a factory. What makes a factory? A factory is essentially a machine, a very large machine, that takes raw material as input and takes energy as input, and it outputs something that's of much higher value than what the inputs are. For example, you might put metals and plastics, put energy in, and out comes a car. That car is worth much more than what the input costs are. Very simply, if you can create such a thing, then your goal is to create more of those and bigger ones, because what you're producing has more value, and hence you have more incentive to build more and more and create more value from this. The nice thing about the kind of factories we're building here is it takes power as input and it takes information, raw data as input, and what comes out of it is refined intelligence, refined knowledge, which is worth much more. Armenia has one resource that we actually have no way of really utilizing properly, and that's energy. We have excess capacity with nuclear, hydroelectric, solar. The potential for energy is much greater, but unfortunately it's not possible to export this in any meaningful way. But if we can convert it through a factory into something of more value, into tokens, into ones and zeros that contain knowledge, those we can actually store and distribute anywhere in the world. So this is the basic economics. Now, what are we producing with these factories? Here behind me, you can see the AI progression we've had over the last 12 years or so. This whole AI thing started back in 2012 in the University of Toronto when two grad students and their professor, Jeff Hinton, Ilya Sutskever, and Alex Krizhevsky, created the first deep learning large neural network to solve a problem that had vexed computer scientists for 5 decades. For 5 decades, we'd been trying to develop an algorithm to be able to tell what's inside an image classification. Say, is this image an image of a dog or a cat? We couldn't do it for 50 years, and then all of a sudden, with this new way of creating software, we solved this problem once and for all. That was AlexNet, not named after Alex Yasayan here. It was Alex Krizhevsky, but it might as well be. Um, when this happened, we understood at NVIDIA that this was going to be a foundational change, a discontinuous change in how all advanced software and frontier computer science was going to happen forevermore. For the first time, we were able to solve this problem in a way that was very different than how humans had solved it before. Up until this moment in time, every algorithm that was ever developed was developed by taking a very smart human, one that knows computer science. That human would sit in front of a simple computer, type up their ideas of what the algorithm should be, and out would come a program that they could go execute. In this new way, we fundamentally changed how this is done because the human no longer actually even understands what the algorithm is. Instead, the human gave many, many examples of what we would like the program to do to a computer, to a very large computer, and it wrote the software for us. We understood this early on and said, well, if you can now solve this problem, what are all of the other problems that we didn't even dream of solving, of writing software for in our lifetimes, that might be possible if we could make computers that were larger and larger, AI factories that were larger and larger, and feed it with more and more information. So it started with AlexNet, with image classification. The first set of AIs we created for the next 5 years or so were all very specialist, narrow algorithms to solve specific problems, largely in perception, things like computer vision, speech recognition, and so on. But these problems, they were narrow and they require a lot of effort to collect the specific data for your narrow problem. Every time you wanted to do something new, you would have to go gather more data and build this thing again. That all changed a few years later in 2017, 2018. The transformer model, the transformer architecture was invented, and that began the age of generative AI. The first GPT was trained. We essentially were able to take all of the information available on the internet and shove it through a big supercomputer, and out came an AI, a model, that had a general understanding of how language worked. Not a specific understanding, but a general one, which allowed it to do many different kinds of tasks, even ones we didn't imagine for it to do. And then a few clicks later, and the act of taking that model and putting it behind a simple web page in ChatGPT in 2022 made everybody understand what the power of this would be, and that journey started. We're now entering the next stage after generative AI, where we're taking this fundamental general intelligence and we're creating systems from them that can do things for us. So the generative AIs that we've had so far, they're largely tools. They're ones where a human goes and uses the ChatGPT or whatever LLM that you're working with as a tool, much like you would any other one. But we're now starting to connect it into systems that act for themselves. We use that same artificial intelligence technology as the core to have systems that can understand and perceive the world, to make a decision upon how to act upon it, and actually go do actions. The first agents we're building largely live inside the virtual world, inside the digital world, inside the world of knowledge, in the internet. They can go do things for us like customer service, or maybe buy concert tickets for you, or go change your calendar. Work with tools that are essentially the tools that knowledge workers use. The next era that's coming, and the one that I've been working towards for the last 10 years, is the most exciting one from my perspective, and probably the largest opportunity in front of us. And this is the physical AI era, where we take these agents that live inside our computers and we give them bodies. We put them out inside the world so that they can do things that only humans used to be able to do, but do them in the physical world. These are our self-driving cars. These are robots that can go work in our factories, in our warehouses. These are agents that can understand the world through cameras and make decisions about what to do inside the world around us. And the opportunity for this is so large, it's hard to even talk about these kinds of numbers. The world of information technology, the markets for information technologies across the globe, is about $5 trillion. That's already an insanely large number. This is where companies like NVIDIA and Google and all the other big tech companies participate in this $5 trillion market. But this market is only about ones and zeros, about digital information. Every other industry, all the industries that relate to atoms of the physical world around us, add up to about $100 trillion. So with this new AI technology we're creating, if we can apply this technology to the physical world, we now for the first time can apply computing as an accelerator, as an amplifier to this $100 trillion industry. You can see some statistics up there of some of the areas in which the AI technologies can apply. The opportunity is massive, and we'd like to participate in that. All right. And with that, I'd like to play a little video for you with some narration from our CEO, Jensen Huang, about physical AI and its origins in Europe, here in Europe.
It began here. The first industrial revolution. Watt's steam engine and the mechanized loom introduced automation and the advent of factories, and industry was born. The age of electricity. Ampere unraveled electromagnetism. Faraday built the first electric generator, and Maxwell laid the foundations for modern electrical engineering. Siemens and Wheatstone's dynamo, the engine of electricity, bringing machines, trains, factories, and cities to life, electrifying the planet, igniting modern manufacturing. And today, born out of the computing and information age, the fourth industrial revolution, the age of AI, reimagining every part of industry. Across the continent, industrial AI is taking hold. From design to engineering, you're blazing new trails toward understanding and reinvention. You brought the physical world into the virtual to plan and optimize the world's modern factories. You're building the next frontier, where everything that moves is robotic. Every car, an intelligent autonomous agent, and a new collaborative workforce to help close the global labor shortage gap. Developers across the continent are building every type of robot, teaching them new skills in digital twin worlds and robot gyms, preparing them to work alongside us in our factories, warehouses, the operating room, and at home. The fourth industrial revolution is here, right where the first began.
So in the video, Jensen talks about the fourth industrial revolution. The second industrial revolution started with the invention of a new technology. It was the technology of generation of electricity. That powered a whole generation of technologies that created opportunities, created productivity. It's hard for us to imagine our world without electricity right now. We take it for granted that it's everywhere around us. Everything that we use, everything that we touch, somewhere was affected by electricity. We pay for electricity and don't think twice about it. We pay for these kilowatt hours. It's a strange concept if you dig into it, where if you go back in time, probably the first people that had to do that couldn't understand, what do you mean you put fuel inside this machine and out comes this thing I can't see, electrons that I have to pay for that somehow have value? We're essentially doing the same thing now. This new industrial revolution that's starting, the one that's being fueled by AI, is actually very similar to that one. With this one, our factory, instead of producing electrons, are producing intelligence. And we produce it in a form called tokens. It's something you can't see. It's kind of hard for us to understand, but it'll essentially underpin everything in every industry, in every application, everywhere, just like electricity does today. So with that, what's important for Armenia is for us to start participating in this new industrial revolution as quickly as possible. And we finally are about to do that. We're laying the foundation in Armenia. Many of you, probably all of you, have heard about this announcement we made back in July for the Firebird AI factory that's going to be built here in Armenia very soon. It's already underway. We made this announcement after many years of working towards aligning everyone together. We finally got just the right mixture with the support of the government of Armenia, combined with the founders. We have Alex Yesayan, Razmik Hovagimian, Nubar Afeyan. I think he might be in here somewhere as he's backstage. The founders, they brought this together with the support of NVIDIA, which we helped bring to Armenia, and the Ministry of High Technology, Mukhitar, and in the picture you can see the Deputy Minister Gevork there. It finally has all come together, and we made this big announcement for $500 million investment, and I think absolutely nobody understood what the hell we're talking about. There's so many questions and so much confusion around all of it. They're like, who is paying for what? What's coming from my tax dollars, et cetera, et cetera. But needless to say, none of you have to worry about anything. Nobody here is paying for anything out of their pockets. It's quite the opposite. Because of the dynamics I was talking about earlier, where these factories take in inputs that are of a certain value, but what comes out is much greater value, there's actually great demand for these types of factories everywhere in the world. You guys have probably been hearing about the massive investments that are being made. There are all the big deals, $100 billion deals that are happening between NVIDIA, OpenAI, Microsoft, Oracle, et cetera. This is actually a pretty small number relative to everything else happening, and we still can't build enough everywhere else. There is so much great demand for this. There's many investors who want to invest, and it's for us to take the opportunity that is in front of us to enhance Armenia. So we are doing it. You can find out more about it. We're going to have a panel later today, I believe, or tomorrow, specifically about Firebird. As I mentioned earlier, these data centers are AI factories. We put in raw information, we put in electricity as inputs, and out come tokens. They're these special numbers that represent knowledge. These can apply to virtually every industry, and fortunately, we are going to have one of these here in Armenia, which is a remarkable thing for a small country of 3 million people to be on one of the first in the world to have such a thing. Imagine this is like if 100 years ago, Armenia was the first country, one of the first countries, to get a power generator to generate electricity. What advantage could Armenia have if it has something like this a few years earlier than everybody else? And what can we do with this? Why is it important that we build this infrastructure here, and what can it amplify for us? Well, first, the actual building and operating of an AI factory is a value itself. This is becoming a multi-trillion-dollar industry in front of our eyes. Those who know how to build AI factories and operate them have an advantage over everyone else. If you go back to the second industrial revolution, the companies that were formed at the time who built the electricity factories, the power generation, became the biggest companies in the world for generations. General Electric, Westinghouse, Schneider Electric, Siemens, and so on. They were all participating in this, and they're still very, very large companies. So if we can train and we can gain the skills of participating in this industry here, we can not only do it for Armenia, but we can export this to everywhere else in the world, because every country, every place in the world is going to need this fundamental infrastructure, just like we need electricity generation, just like we need telecommunications, just like we need water and roads and everything else. Intelligence infrastructure will be everywhere, and our people, our country, will have a head start in this knowledge and participating in this ecosystem. Once you have this infrastructure, you can also use it to amplify higher education, to amplify basic research inside Armenia, inside your country. The fundamental tool for computer science and computer engineering today is a supercomputer. It's an AI supercomputer. The richest universities in the world, Stanford, MIT, the top universities in computer science, they don't have these tools. All of the best students, all of the professors at these universities have to come work at NVIDIA, have to go work at Google, they have to go work at Microsoft so they can get access to the basic tool. It's very similar to how a particle physicist needs their basic tool of a large piece of infrastructure, like a linear accelerator. You need this here. So by having it in Armenia, and by allocating a good portion of this to our educational institutions, to our startups, we will seed the ecosystem such that we can attract talent from outside to train up our locals here on frontier computer science, and we will create startups, and we will amplify the existing companies that already exist here. And once that happens, then there will be more demand for more AI infrastructure, so we'll get to form a nice loop here, where all of it feeds on itself and keeps building into a flywheel. Another interesting thing about this technology that is very different from all of the technologies that preceded it, the way economists think about technology is anything that makes a human more productive. These are tools. Generally, if you give a human a tool that makes them more productive, like a shovel or a horse or a truck or a microscope, then they can do more things and create more value. But small countries, all countries really, but especially small countries, are limited by the potential number of laborers they have. No matter how great your technology is, you cannot do more than what the number of people you have in your country allow you to do. For the first time, we have a technology where by itself it can actually start creating value in the form of GDP. They're the equivalent to laborers participating in our economy. We have agents that will work in the knowledge space. They'll be like knowledge workers. And soon we'll have physical AI, robots that can work autonomously, that act like physical laborers. So for Armenia, this is particularly important when you are challenged by the size of your population relative to other countries, if you have the infrastructure to construct artificial laborers, we can potentially increase our GDP, not just by enhancing the humans that we have, but by adding other laborers to our workforce. So with that, I actually can't tell how much time I have left. There was supposed to be a timer over here, and it's not there. All right, I've got 5 minutes. Perfect. With that, NVIDIA is supporting every country in the world, every place in the world, to go build this infrastructure, to go build on top of this infrastructure, to take advantage of this great opportunity in front of us. And Armenia is also a participant in this. We have a presence here. We have a large number of employees in our office here that work locally. We also provide many programs to help higher education and help enterprises, companies, and startups. One program we have that's really terrific, it's called Inception. For if you have a great idea for a startup company or you already have a startup and you need resources to navigate through the world of AI, the tools of AI, through the technologies that NVIDIA has available with support from us, please go apply for the Inception program. It is wide open to everyone, and I encourage all Armenian companies to do this. We also provide training, certifications, and workshops that are both self-serve and human-led through our various programs. Please take advantage of that. And finally, now that NVIDIA has some money, you know, we've been making a little bit extra in recent years. We actually have a venture fund, and so we are investing in large and small companies alike through our NVentures program. So if you have a company that is working on something amazing, that is within the strategic direction of all of the things that NVIDIA is supporting, then you're potentially a good candidate for us to invest in as well. And I urge you to take a look at that. And with that, I'd like to leave you with this final slide, my favorite one. Up here, I have a list of many organizations, companies, universities, and various institutions for education and business that are all participating in computer science and AI in Armenia today. Some of them are international companies that have a large presence here, but most of them are Armenian homegrown. This is really, really special. If you look at many of the countries in our region and even further out, ones that are much larger than us, they can't list this many logos up there. And so this is a testament to the hard work and the efforts and the passion and dedication for many of the people that are here in this room and participating in the conference today, and many of the Armenians everywhere in the world who are contributing to it. But it's only the beginning. I would love to see in 5 years, this should be 10 times the number of logos up there. All right, with that, have a great DigiTec. Thank you, everybody.